There are lots of really good Modbus software tools out there. In this section, however, I'm going to use the software tools that I have used over the years and continue to use. The two main software tools that I use are ModScan32 and ModSim32. ModScan32 is a Modbus master/client simulator. I call it master/client because when we're dealing with RS-485, we call it a master. When we're dealing with Modbus TCP/IP, we call it a client. Similarly, we use the same sort of naming convention for ModSim32. It's a slave/server, a slave when we're dealing with RS-485, server, TCP/IP. Both simulators are made by a company called Wintech. So here we have the two software tools that you will need to download, install, and use in this section. Great. All right, so we have set up the ModSim32 with a holding register which is address 21, and it's just one in length, one of them, and it has a value of 1,000 right now. And what I did here, I can just sort of delete this and put it back in for you, is that I went into device 21. I removed the right single coil, 4 single coil, and I'm going to click add right here, preset single register, and that's 21, and the value is 500. Click OK there, and I'm just going to move this into place so you can see it very easily there, and click poll. All right, so this has changed to 500, and this is our actual hexadecimal data stream. 15 is hexadecimal for 21, 6 is the function code, and 14 here, that is actually 21. Okay, sorry, that's actually 20, decimal 20, because remember, you take the address 21 here, sorry, you take the address 40,021 and you minus 40,001 and you get 20 there. And then 01F4 is actually 500, okay? And the response is a reflection. It just reflects the entire stream. Again, you're not seeing the mbap header, but still, you can still use this for diagnostic functions and that kind of thing. All right. So we have a simulation there, and we see right single register. Okay. Now this brings us to the end of the simulations. But what I want you to do is, if you haven't before, go back to the simulations, download all of the software, ModScan32, CAS Modbus Scanner, ModSim32, and actually make an effort to run these simulations yourself, because there's nothing like learning through doing. All right, and this is how you will get familiar with Modbus. Great. Okay, so thus far, what we have been doing is we've been using these simulators, and we've been looking at the data streams, and those data streams, the values in those have been expressed in decimal format. However, Modbus documentation for many devices and also for many simulators, what they show is a hexadecimal representation of the data streams, the query and response data streams. So what I want to do is just give you an example of that and show you that, so that when you see it live in the field, you won't be intimidated by it, right? So you need to know some hexadecimal if you're going to deal with Modbus and troubleshoot Modbus. Okay, so what I'm going to do here is that you would notice that this button was on decimal. I'm going to click hexadecimal here. I'm going to click data traffic, right? And we'll be doing our read of a coil status before, and I'm going to connect, and let's see what happens there. All right, disconnect. Okay, so what I have here, this is really a hexadecimal representation. So what I have is this is the transaction identifier, protocol identifier, and this 6 here, well, 6 is 6 in decimal and hexadecimal. This 6 here is the number of bytes to come. And 15, this is not 15, this is 15. This is really hexadecimal representation for 21. This is the unit ID. Okay, and then 1 is the actual function, and then we have the start address and the number of memory locations to be read. So this is a hexadecimal representation, and with different data streams, you're going to actually see the letters A and E and D and so on, which is part of the hexadecimal standard. All right, so you'd notice that everything is 2 digits. Everything is 2 digits, and that's what hexadecimal is. Hexadecimal works very well with binary in the sense that each digit represents 4 bits then, right? So 2 of them is 8 bits and this is a byte right here. So that's the hexadecimal format that I just wanted to get familiar with. In the next 2 videos, we're actually going to be looking at using the CAS Modbus scanner, and all the CAS Modbus scanner uses is hexadecimal format. That's why I'm introducing it to you here now. All right, so here we have ModSim 32 once again, and we have it set up at this coil status, our same coil, which is 10. I'm going to start the CAS Modbus scanner, right? And it asks me, would you like to create some tasks? Okay. So here's what we're going to do. First, we have to add a connection. So we have the serial connection here, and then we have the TCP connection here. So what I'm going to do is I'm going to add my IP address right here, port 502, timeout there, and add TCP connection, and we have that right there. Okay, then I'm going to add device. The ID is 21 because it's 21 here. And then I'm going to add a write. Right, a 4 single coil and 10, and let's say the value is 0. Okay, and then I'm going to click off, and then I can do edit. I can add another request. I can add, another write. Force this value to 1. Offset of 10. There we go. Okay, so I have a write coil to 0 and write coil to 1. And that's my coil right there. So let me see if I can make this a little more. Right, so that's one there. I'm just trying to get everything on the screen so you can see the 1 or 0 right here, right? So I'm going to activate this now. I've clicked on this and we're going to go pole. Right, and you see that goes to 0 there. Now, what you're seeing here, of course, is the actual pole. And this 1.5 is actually 21 decimal. And this 5 here is a 4 single coil command. And then there's 9, which is 10 minus 1. Remember, it's 10 is the actual coil address, and 10 minus 1. 1 is the lower limit of a coil, the coil region. And this is what to write to it, which is 0, 0. Okay, and if I go here and do pole and write it back to 1, and same thing here as this is 21 decimal, 4 single coil, but we're forcing it to FF, and that is really how you force it to 1. Now notice that CAS Modbus scanner does not show you the MBAP header, right, with the transaction identifier, pole identifier, and protocol identifier and length and so on, right? It just has the unit ID and the rest of it there. But notice there's no CRC at all. Okay, so that's a 4 single coil, and that is what it looks like using the CAS Modbus scanner. All right, so we've successfully seen the data streams for that, even though we can't see the MBAP protocol header. Okay,